Now next is absolute maxima and absolute minima. That is absolute maxima oblique minima. So absolute maxima oblique minima implies the greatest and the least value of the function in the interval. That is the greatest possible value and the least possible value of the function in the interval. So what is the criteria to find here is, for example, we have the question fx is equal to 2x cube minus 24x plus 107 in the interval 1, 2, 3. So same way, first of all we will find the derivative, which is your 3x square minus 24 equated equal to 0 implies x square minus 4 equals to 0. This implies x is equal to 2 belongs to 1, 2, 3 here. Whenever the question is to find the greatest and the least value, of the function, or the absolute maximum and absolute minimum value of the function, then what should be the next step? Find f of 1. 2 minus 24 plus 107. 109 minus 24, which is 84. 5. Find f of 2, that is through the critical point. 2 into 8 minus 48 plus 107. How much is that? 16. Minus 32 plus 107, which is your 75. Find f of 3. This is your 54 minus 72 plus 107. How much is that? Minus 18 plus 107, which is your 89. So absolute maximum value is 89. Absolute minimum value is 75. Absolute maximum occurs at x is equal to 3 and absolute minimum occurs at the point x is equal to 2 here. Now similarly the next one is, say we have fx is equal to, this is sin x plus half of cos 2x in the interval 0 to pi by 2. Find f dash x. This is cos x plus half of minus 2 sin 2x. So this is cos x minus sin 2x equated equal to 0 implies cos x minus 2 sin x into cos x equals to 0 implies cos x into 1 minus 2 sin x equals to 0 implies x is equal to 90 degrees or sin x is equal to half, that is x is equal to what is that, 30 degrees here. Since we have to find the absolute maximum and absolute minima, f of 0, it is 0 plus half, this is equal to half. F of pi by 6, that is your sin 30, which is half, plus half of, that is your cos of 2 into pi by 6, which is half, plus half into half, which is your half, plus 1 by 4, which is your 3 by 4. And next one is f of pi by 2. This is 1 plus half of cos pi. 1 minus half, this is half. So absolute maximum value is 3 by 4. It occurs at the point x is equal to pi by 6. Absolute minimum value is half, which occurs at 0 as well as pi by 2. So this way you can find the absolute maximum and the absolute minimum value of the function here. Now next question is, if y is equal to ax minus b upon x minus 1 into x minus 4 has a turning point, has a turning point at p, which is your 2 minus 1, then find the values of a and b and show that it is maximum at p. So this curve, this function has turning point at p 2 minus 1. We have to show that, we have to find the values of a and b and show that it is maximum at p here. Now curve turns at the point 2 minus 1 implies 2 minus 1 lies on the curve. So therefore minus 1 is equal to 2a minus b upon 1 into minus 2. So 2 is equal to 2a minus b. So this is the relation which we are getting here. Further, dy over dx at x is equal to 2 is 0. So this implies x minus 1 into x minus 4 into a minus ax minus b into x minus 1 into 1 plus x minus 4 into 1 upon x minus 1 into x minus 4 whole square is your dy over dx. So dy over dx at x equal to 2 implies that you can see that this is your 1 into minus 2 into a minus this is 2a minus b into 1 minus 2 because 1 minus 2 upon this is 1 into minus 2 whole square is equal to 0. So this implies that minus 2a plus 2a minus b equals to 0. Minus 2a, this will be minus 1 minus 2 minus plus 2a. So this implies b equals to 0. B equals to 0 implies from first a equals to 1. So we have the values of a and b. Now we have to show that this function has got maximum value at p2 minus 1. Now that means you can see that dy over dx is equal to, since a is 1, it is x minus 1 into x minus 4 minus what is that, x into this is your 2x and minus 5 upon x minus 1 into x minus 4 whole square. So dy over dx is equal to, this is your x square minus 5x plus 4 minus 2x square plus 5x upon this is whole its square upon x minus 1 into x minus 4 and its square. So which is your minus x square plus 4 upon x minus 1 into x minus 4 whole square. So it is minus of x minus 2 into x plus 2 upon x minus 1 into x minus 4 and its square. So this is your 2 here plus minus minus plus. That is because of the negative sign. You can see that curve derivative changes its position from positive to negative through x is equal to 2. This shows that function has got local maximum at p, which is your 2 minus 1 here. We will discuss the application of maxima minima in solving the problems relating to, let's say, area, volume, etc. Now first question is, find two numbers whose sum is 24. Find two numbers whose sum is 24 and whose product is as large as possible. Now what do you mean by as large as possible? That means maximum. So this signifies that we have to maximize the product when it is given that sum of the two numbers is 24. Now let the two numbers be x and y. What is given to us? X plus y is equal to 24 implies y is equal to 24 minus x. Product of the two numbers is x into y, which is your x into 24 minus x. Now dp over dx is equal to d over dx of x into 24 minus x, which is your x into minus 1 plus 24 minus x into 1. It is minus x plus 24 minus x, which is your 24 minus 2x. So accordingly you equate dp over dx equals to 0. This implies x is equal to 12. Find out the second order derivative, which comes out to be minus 2, which is less than 0, implies maxima. So we have the product maximum when x is 12. X is 12 implies y is also 12. So the two numbers are, that is 12 and 12 here. Now next question is, show that of all the rectangles with a given perimeter, show that of all the rectangles with a given perimeter, the square has the largest area. The square has the largest area of all the rectangles with a given perimeter. Let's say this is your rectangle with sides x and y. Perimeter, which is your 2 times of x plus y, is given. So this implies p by 2, it is p by 2 minus x is equal to y. What is the area of rectangle? It is x into y. We have to show that square has the largest area. That means area of this rectangle is maximum when it is a square. Let's see how we can prove this. So this is x into y is your p by 2 minus x. It is px by 2 minus x square. So dA over dx is equal to, it is p by 2 minus 2x equated equal to 0. This implies x is equal to p by 4. What is d2a over dx square? It is minus 2 less than 0, implies maxima. So it is maxima when x is equal to p by 4. Now x is equal to p by 4 implies y is equal to p by 2 minus p by 4, that is also p by 4, which clearly shows that this area is maximum, area of the rectangle is maximum when it's a square. Next is, show that of all the rectangles inscribed in a given circle, show that of all the rectangles inscribed in a given circle, the square has the maximum area. The square has the maximum area. Now, of all the rectangles inscribed in a given circle, what do you mean by this? That means the radius of the circle is given to us. Circle is given to us means that we know what is its radius. So this is a circle. Now this is the rectangle which is inscribed in it. Now this is the radius r. Let us say it makes an angle theta with the, that is your horizontal. Now if this point is O, this point is A, this point is B, this point is C, this point is D, this point is E. Now you can see here, can I say that it is r sine theta and this is r cos theta, using the definition of cos theta for this triangle and sine theta for this triangle. Now show that of all the rectangles inscribed in a given circle, the square has the maximum area. So therefore AD is equal to 2r sine theta, AB is equal to, it is 2r cos theta, and AB is equal to 2r sine theta. So what is the area of rectangle? So area of rectangle is, that is your 4r square sine theta into cos theta. which is 2r square sine 2 theta. Now d over d theta of area, let's say this is area, so what is that? It is d over d theta of 2r square sine 2 theta, which is your 4r square cos 2 theta equated equal to 0. This implies cos 2 theta is 0, implies 2 theta is 90, implies theta equals to 45 degrees. So theta equals to 45 degrees, second order derivative. This is your minus 8r square sine 2 theta. At theta equals to 45, this is minus 8r square negative, implies maxima. So you can see here, question was show that of all the rectangles inscribed in a given circle, square has the maximum area. You can see that area is maximum when theta is 45. So theta is 45 implies AD is equal to 2r cos 45, which is your 2r over root 2, and AB is equal to 2r over root 2, which clearly shows that it's a square. So hence of all the rectangles inscribed in a given circle, this square has the maximum area. Now next is prove that the area of a right angle triangle of given hypotenuse. Prove that the area of a right angled triangle of given hypotenuse is maximum when it is isosceles. That is, area of a right angle triangle is maximum of given hypotenuse is maximum when it is isosceles. So this is your right angle triangle, ABC, right angled and C. Let's say this is your given hypotenuse, let's say it is H, and this is your variable angle theta here. So again, we have AB is equal to H cos theta and BC is equal to H sin theta. Area is equal to half of base into height, which is your half of, this is H square sin theta into cos theta. So can this be written as H square by 4 into 2 sin theta cos theta, which is your H square by 4 into sin 2 theta. So dA over d theta is equal to H square over 4 into 2 cos 2 theta. When you equate it equal to 0, implies cos 2 theta is 0, implies 2 theta is 90, implies theta is 45 degrees. Now you can see here dA over d theta is H square by 2 cos 2 theta. d2a over d theta square is minus H square sin 2 theta. When theta is equal to 45 degrees, implies d2a over d theta square is minus H square, which is negative, implies area is maximum. So this implies area is maximum when AB is equal to H cos 45, that is your H over root 2, and BC is equal to H sin 45, which is your H over root 2, that is the triangle is isosceles here. That means it is isosceles right angle triangle. Now similarly the next question is show that triangle of maximum area. Show that triangle of maximum area that can be inscribed in a given circle is an equilateral triangle. So what is the question? Triangle of maximum area that can be inscribed in a given circle. Given circle means that we know that what is its radius here. So this is your radius R. Now let us say this is your triangle ABC here. Now if this is theta, let's say it is O, say it is D, can I say that OD is equal to R sin theta and BD is equal to R cos theta? The question is triangle of maximum area. So area of triangle ABC is equal to half of base, that is your BC, into height, which is your AD. Base is your 2 times of BD, which is your R cos theta, and AD, can I say that it is R plus R sin theta? So you can see here it comes out to be R square cos theta into 1 plus sin theta. So let's say area is A. What is dA by d theta? It is R square into, this is your 1 plus, it is sin theta. So dA over d theta is R square into, this is cos theta into cos theta plus 1 plus sin theta into derivative of cos theta, which is your minus sin theta. So this is equal to R square into cos square theta minus sin theta plus sin square theta, you can see here. So this comes out to be equal to R square into 1 minus sin theta. So when you equate it equal to 0, that is your sin theta equals to 1 implies theta equals to 90 degree. Now let me once again check the solution of this. So area of triangle of maximum area. So this is R sin theta. That means it is R plus R sin theta. This is R cos theta, 2 times of R cos theta. So this will cancel. R square is common, cos theta into 1 plus sin theta. So derivative of sin theta is cos theta plus, here it is 1 plus sin theta. So which means that this is R square into cos square theta minus sin theta minus sin square theta. So this is R square into cos square theta minus sin square theta minus sin theta. So we have dA over d theta is equal to, that is R square into cos 2 theta minus sin theta. So this is the derivative. We will convert cos 2 theta to 1 minus 2 sin square theta. This is 1 minus 2 sin square theta minus sin theta, or equate it equal to 0. So this implies that 2 sin square theta plus sin theta minus 1 equals to 0, or sin theta equals to minus b plus minus root b square minus 4ac over 2a, that sin theta comes out to be equal to minus 1. Sin theta minus 1 means that theta equals to, what is that? It is 270 degrees, or theta equals to 30 degree here. Now, so this implies that theta equals to 30 degree. Now, find the second order derivative. D square a over d theta square, it is R square into derivative of cos 2 theta minus 2 sin 2 theta minus cos theta. When theta equals to 30 degree, this is R square into minus 2 sin 60 minus cos 30. You can see that it is less than 0. Less than 0 implies it is maximum. Now we have to show that this triangle is that is your equilateral triangle here. Now what is this? From here you can see that we have the that is your BC. What is BC? It is 2 times of BD. What is BD here? It is 2 times of r cos theta. That is your 2r into cos of 30 degree, which is your under root 3 r by 2 here. That is 2r cos theta is your BD. So it is 2r into cos 30. That is your, this is your, it is under root 3 cos theta is root 3 by 2. It is 2r into under root 3 by 2, which is your root 3r here. Now this is 30 degree here. Now that means this is 30 degree. So that means your, this is 120 degrees. So this one will be 60 degree. So this clearly shows that this is your equilateral triangle here. Now next is, a figure consists of a semicircle. A figure consists of a semicircle with a rectangle on its diameter. Given that the perimeter of the figure find its dimensions in order that its area is maximum. A figure consists of a semicircle with rectangle on its diameter. Now you can see here, this is the rectangle and this is your semicircle here. Now this is the figure ABCD. Figure consists of a semicircle with a rectangle on its diameter, given that the perimeter of the figure. Now let us say this is your x and this is your y. Now perimeter of the figure, say, is P. So therefore P is equal to x plus 2y. Because we will not consider the length CD here. Perimeter means the outer boundary. So x plus 2y plus half of 2 pi into r. Because this whole is x, half of it will be x by 2. So radius is x by 2 here. So what is that? It is x plus 2y plus pi x by 2. So once again you can see here, perimeter is x plus y, that is your x plus 2y, plus half of 2 pi into r. Now you can see that since this is your x by 2, this is your x by 2, so this is your x by 2. So half of 2 pi into radius, which is your x by 2, so it becomes pi x by 2 here. Now figure consists of a semicircle with a rectangle on its diameter. Given that the perimeter of the figure, find its dimension. Given that the perimeter of the figure means that perimeter is constant, find its dimensions in order that its area is maximum. Now what is the area of this figure? It is xy plus half of pi r square. Since it's a semicircle, so obviously the radius will be half of it, half of pi x by 2 whole square. Now this is equal to xy plus pi x square by 8. Now from here, can I say that y is equal to p minus x minus pi x by 2 upon 2? That is p minus x minus pi x by 2 upon 2. which means that this is your x into p minus x minus pi x by 2 now upon 2 plus pi x square by 8, which is your x into 2p minus 2x minus pi x by 4 plus pi x square by 8, which is your px by 2 minus x square by 2 minus pi x square by 4 plus pi x square by 8. So if we simplify this, it comes out to be px by 2 minus x square by 2. What is that? Minus, this is your pi x square by 8 here. Now this is the area here. So if we differentiate this, you can see that d over dx is p by 2 minus 2x by 2 minus 2 pi x by 8. This is the differential of the area. So equated equal to 0. This implies p by 2 is equal to x plus pi x by 4. So it is 4x plus pi x by 4, which is your p by 2. So this implies 2p upon pi plus 4. This is equal to x. That means we have one length of the rectangle as, or one side of the rectangle we have been able to calculate as 2p over pi plus 4. Now question is, semicircle with a rectangle, given that the perimeter of the figure, find its dimensions in order that its area is maximum. Now if you differentiate it second time, you can see that it will come out to be minus 1 minus pi by 4, which is negative, implies area is maximum. Now where is y? This is 1, this is 2. So from first and second, what is y? It is p minus 2p by p plus 4 minus pi by 2 times it is x, which is 2p over p pi plus 4 upon 2. So this will cancel. So what is that? It is p minus, if I take p over pi plus 4, or okay, we will simply take the LCM of this. It is p pi plus 4p minus 2p minus p pi upon 2 times it is pi plus 4. This will cancel, or it is 4p minus 2p is 2p, that is your p over pi plus 4. So we have the values of x and y. On the basis of this, area of this figure is maximum when these are the lengths of the corresponding sides of the rectangle. Now next question is, a square piece of tin of side 24 centimeter. A square piece of tin of side 24 centimeter is to be made into a box without top by cutting a square from each corner and folding up the flaps to form a box. Now what should be the side of the square to be cut off so that the volume of the box is maximum. So very important for me to write down the statement first here. Now you can see here, this is a square piece of tin and each length is 24 centimeter. Now a square is cut from each corner. Now let's say length of the side of the square to be cut off is x. If this length is x centimeter, this length is x centimeter, total is 24. Can I say the remaining length will be 24 minus 2x? Similarly x, so this length will be 24 minus 2x. Now we will cut these, that is like this, and these flaps. Now we will fold up the flaps and you will have a box without top. So what is the volume of the box? You can see here it is 24 minus 2x, length into breadth into the height. So this is equal to 24 minus 2x whole square into x. Let's say this is your volume. Then what is dv over dx? It is 24 minus 2x whole square into 1 plus x times 2 times 24 minus 2x into minus 2. So if we take 24 minus 2x common, you can see here it is 24 minus 2x. Now minus 4x. This is equal to 24 minus 2x into 24 minus 6x. Equated equal to 0. This implies x is equal to 12 or x is equal to 4 here. Now again you differentiate this. d2b upon dx square is equal to 24 minus 2x into minus 6 plus 24 minus 6x. This is your 24 minus 6x into minus 2. Now x is equal to 4 implies, what is that? d2b upon dx square is 24 minus 8 into minus 6 plus 0. How much is that? It is minus 96, which is less than 0, which means that it is maximum. So the volume of the box is maximum when x is equal to 4 centimeter. That is, side of the square to be cut off is, that is your x is equal to 4 centimeter here. Now next is find the volume of the largest cylinder. Find the volume of the largest cylinder that can be inscribed in a sphere of radius r. Find the volume of the largest cylinder. So find the volume of the largest cylinder that can be inscribed in a sphere of radius r. Sphere of radius r means, that means the radius of sphere is given and cylinder is inscribed in a sphere. Now this is the diameter of the sphere. Let's say this is the center of the sphere. Now radius is r. Let's say this makes an angle theta with the horizontal. If this is A, B, D, E, now can we say that this length is equal to r sine theta and this length is equal to r cos theta, so that height h is equal to 2r sine theta and radius is equal to 2r cos theta. Sorry, radius is equal to r cos theta. This is the radius of the cylinder. This is 2r sine theta is the height of the cylinder. Now volume of cylinder is, we know that pi into radius square into height. So what is that? It is pi into r cos theta square into height, which is your 2r sin theta. Can I write this as 2 pi r cube into cos square theta into sin theta? Now you differentiate this with respect to theta. It is 2 pi r cube into cos square theta into derivative of sin theta is cos theta plus sin theta into 2 cos theta into minus sin theta. So this is the differential of, that is your volume with respect to theta. So this can be written as 2 pi r cube into cos cube theta minus 2, what is that? It is sin square theta into cos theta. So if we take cos theta common from here, you can see that it is cos square theta minus 2 sin square theta equals to 0. Now from here, if I equate it equal to 0, cos theta equals to 0 implies that is your theta equals to 90 degree, which is not possible. So this implies cos square theta is equal to 2 sin square theta, or that is your tan square theta equals to half. Now tan square theta is equal to half implies that tan theta equals to 1 over root 2. So through the triangle you can see that this is 1, this is root 2, then this has to be root 3 here. We will use these values to show that second order derivative at these values is, because largest, that means the second order derivative should be negative. Now from first, or you can say that this is the first here. From first d2y v upon d theta square is equal to, this is your 2 pi r cube into 3 cos square theta into minus sin theta minus 2 times sin square theta into minus sin theta plus cos theta into 2 sin theta into cos theta. Now this is equal to, it is 2 pi r cube into minus 3 cos square theta into sin theta plus 2 sin cube theta. What is that? It is minus 4 sin theta into cos square theta. So it comes out to be 2 pi r cube minus 7 sin theta cos square theta plus 2 sin cube theta. If we substitute the values of, that is sin theta and cos theta using this triangle, you can see that it is 2 pi r cube into minus 7 sin theta. Sin theta is how much? 1 over root 3 cos theta. It is 2 by 3 plus 2 sin theta. It is 1 over 3 root 3, which is negative, which clearly shows that the volume of this cylinder is maximum, and when it is inscribed in a sphere of radius r. Now next question is, find the point on the curve. Find the point on the curve y square is equal to 4x, which is nearest to the point 2, 1. Now let the point on the curve be hk. So therefore k square is equal to 4h. Now distance which is nearest means that we have to show that the distance between the point on the curve and 2, 1 is minimum. Now distance is given by h minus 2 whole square plus k minus 1 whole square and its root. Now since it is always positive, so whether you find the minimum of this or this is one and the same thing here. So let us say this is equal to any figure, say it is a here. So we have a is equal to, this implies that h is equal to k square by 4. K square by 4 minus 2 whole square plus k minus 1 whole square. dA by dk, this is 2 times k square by 4 minus 2 into 2k by 4 plus 2 times k minus 1 and equated equal to 0. So this implies that k cube minus 8k plus 8k minus 8 equals to 0, or this implies that k is equal to 2. Now if we further find its derivative, d2a upon dk square, you can see that k square by 4 minus 2 into 1 plus k into 2k by 4 plus 2. If I put k equals to 2, k equals to 2 implies this is equal to, this is your 4 over 4 minus 1. Now if we take k equals to 2, that is your k square by 4, that is your plus 2 which is your 3 greater than 0 implies minima. So hence it is minima, or it is the nearest to the point 21 when k equals to 2. So k is equal to 2 implies that is your h is equal to 4 by 4 1, and hence the point is that is your 1 2 here.